Hello everyone, we are starting with coordinate geometry, lecture number 3. This time our focus is on equation of a line. Now previously we have talked about the basic concept, the idea of coordinate axes. We talked about points, we talked about midpoint, and we talked about the distance between 2 points on that plane, on the Cartesian plane that is. And we also talked about slope, incline, gradient of a line. And let's continue our journey with the concept of slope. So we know that M, that is the symbol for slope, that is the symbol for incline. We use the terminology gradient. That is change in y over change in x. This can also be termed as rise over run. And the formula that we use is y2 minus y1. That's the change in y divided by x2 minus x1. Let's say there is a point A, the coordinates are x1, y1. There is another point B, the coordinates are x2, y2 respectively. So what is the formula for gradient? That is right over here. So now there are two formats of equation of a line that we use. The first format, that is the most common one, which you have used in O levels or IGCSE, that is y is equals to mx plus c. Now we have m. M is the slope, M is the incline, and we have C. C is the y-intercept. So therefore, the name of this format is slope, and y-intercept, we just write intercept over here. So this is the slope-intercept form or format. That is the one that we used. And now let me introduce the second format. That is y minus y1 is equals to m bracket x minus x1. So there could be a point, and the point is x1, y1. Put a comma over here. There is the slope, that is the gradient, that is right over here. And let me illustrate, highlight this thing in green color. So we have a point, we have a slope, and hence the name, that is the point slope format or form. So in AS level and in A levels, we mostly use the point slope format. There is nothing wrong with y is equals to mx plus c format, but this new format is easy to use. Why? Let me just illustrate it to you. So now first of all, let me grab a straight line like this. So that is a line segment. And let me mark this point as A, which is 0, 1. Let me mark this point as B, which is 5, 11. Now I'll do these problems in both the formats, and then it's up to you to decide which one is the easier one for you. So over here, first of all, let me write it again. This is 0, 1. This is B, 5, 11. I draw an arrow like this to show that this is the direction in which I'll be doing the subtraction. So first of all, the gradient, that is y2 minus y1 over x2 minus x1. So basically, this is y2, this is y1. So this is 1 minus 11. Similarly, this is x2, this is x1. So this is 0 minus 5. So what do I have? I have m. This equals to negative 10 divided by negative 5, which comes out to be positive 2. So that is the gradient right over here. And over here, when we talk about y-intercept, what does it mean? It means line cuts x-axis. So when a line cuts x-axis, the y-coordinate is 0. So when the y-coordinate is 0, isn't this the point that we are talking about? So we can see with our own eyes that the value of C, the value of y-intercept is 1. Now let's say someone forgot this basic concept. They should not, but they forgot it. So what is the approach then? So first of all, I'll write y is equals to mx plus c. I'll insert the value of m, which comes out to be 2. I'll rewrite it again, y is equals to 2x plus c. I can plug in any point. So let me plug in 511. And why are we plugging in? So that we can evaluate c. So therefore, I'll write y is equals to 2x plus c, and then I'll plug in 5 and 11. 5 goes over here, 11 goes over here. This is 11, this is 2, this is 5 plus c. 11 is equals to 10 plus c, make c the subject. C comes out to be 11 minus 10, which is 1. Definitely, it was very, very obvious over here, but sometimes people forget. So there is nothing to worry. You get the y-intercept right over here. So in the end, what do we have? We have the equation of a line, y is equals to 2x plus 1, and that is what we were looking for. So now we have used one method. It's time to try out the other method. So let me draw the line segment once again. This is the point A, 0, 1. This is the point B right over here, that is 5, 11. We have already calculated the gradient, which is 2. Let me write the format y minus y1, use a bracket, equals to mx minus x1. Now over here, the value of m is right over here. And what about x1, y1? So this is x1, which is 5. This is y1, which is 11. And let me just switch the place. I think I wrote it in the wrong manner. Okay. So now x1, and that is some mistake that people make. So this is x1, which is 5. This is y1, which is 11. And the rest of the thing is the same. Y minus 11 is equals to 2x minus 5. So now just open up the bracket. So y minus 11 is 2x minus 10. Y is equals to 2x minus 10 plus 11. Therefore, y is equals to 2x plus 1. And that's the equation of a line. So you don't have to worry about calculating c separately. It just comes out automatically. So now let me also use some other values. Let's say worked example 2. So the previous one was worked example 1. Now this is worked example 2. Let's say the gradient is given as 3/4. And what else is there? Let's say a point Q is given, a 5, minus 3. Find the equation of a line. Y minus y1 is equals to mx minus x1. This time the gradient is 3/4. That will go right over here. And the x coordinate will go over here. This time I'm not going to make any mistake. And the y coordinate will go over here, because first is x, then it's y. But in this equation, y is on the left, x is on the right. So therefore, let's get started. Y minus y1. Y1 is minus 3 is equal to m, which is 3/4 x minus 5. So now there are two things that I need to consider. The first thing, that is the negative sign. Y minus minus 3 becomes y plus 3. Still use a bracket, is equals to 3/4 x minus 5. Now there are two approaches. Either I multiply this fraction only on the right hand side and then open it up and then deal with fraction. I personally prefer using cross multiplication. So 4 multiplies with y plus 3, and on the right hand side 3 multiplies with x minus 5. Now open up the bracket comfortably. 4y plus 12 is equals to 3x minus 15. Now someone can ask this question, that if the examiner only says find equation of a line, so you're all good over here. That is the equation of a line and you will gain full marks. But what if the examiner says write the equation of the line in the form, and that particular format is given, that is ax plus by plus d equals to 0. Now what will you do? You want everything on the left hand side. You want an x term first, then a y term, then a constant, and then 0 on the extreme right. So for that matter, this is the format that is necessary. So let me continue with the working. So we have 4y plus 12 is equals to 3x minus 15, 4y minus 3x plus 12 plus 15 is equals to 0. Negative 3x plus 4y plus 27 equals to 0. Yes, this is of this format, which is ax plus by plus d equals to 0. Maybe the examiner will say, state the values of a, b, and d. So you will do comparing coefficient. You'll say a is negative 3, b is positive 4, d is positive 27. Now someone can raise this question, what if the 0 was on the left and everything else was on the right? That is perfectly acceptable, which means that all these signs will change, and this will be 3x minus 4y minus 27 equals to 0. This is also perfect, no issue. The value of a could be negative 3, the value of a could be positive 3. Similarly, b could have the sign change, d could have the sign changed, as long as you have the correct format, which is ax plus by plus a constant equals to 0. That is perfectly good. Now, one other thing, something very, very common that people get mixed up with, that is the concept that this is the y-axis and this is the x-axis. So just some basic thing, the x-axis is also known as y is equals to 0. That's the equation of a line. Why? Because if I look at the coordinates, let's say this is 1, 0, and this is 2, 3, 4, 5, this is 5, 0, and so on. All along the x-axis, the y coordinate is 0. So that is the equation. Similarly, if I just scroll down a bit, similarly, if we have the y-axis, this is known as x is equals to 0. For example, this is 0, 1. For example, this is 0, negative 1. For example, this is 0, 3. So all along the y-axis, the x coordinate is unchanged. So let me rewrite over here. When we have the y-axis, the equation is x is equals to 0. When we have the x-axis, the equation is y is equals to 0. That is why when we say line intersects or intercept the x-axis, so we say y is equals to 0. That is this thing right over here. And when it says the line intersects y-axis, therefore x is equals to 0, that is right over here. And also we should be aware of the fact that, again, let me draw a grid, and this time I'm drawing a green line that is parallel to the x-axis. Now this green line is passing through the y coordinate too. The gradient of this line is 0. Why it is 0? Let me choose 2 points over here. This is 1, this is 2, this is 3, this is 4. So let me choose 1, 2, and let me choose 4, 2. So the gradient is, let me write over here, 1, 2, 4, 2. Let me draw this line like this. 2 minus 2 over 1 minus 4, which is 0 over negative 3, which comes out to be 0. 0 divided by any number is 0. When the gradient is 0, y is equals to mx plus c. The m part is 0, so what am I left with? Y is equals to c. That means a line parallel to x-axis. And let me draw the parallel in this manner. A line parallel to x-axis will have the equation y is equals to a constant. that constant is the y coordinate, because all along the line the y coordinate is unchanged. Similarly, if I again draw a line in white, that is the y-axis, that is the x-axis, and I'm drawing a purple line that is parallel to y-axis. So let me mark some points over here. This is the y-axis, this is the x-axis, this point is let's say 3, 0, and this is 3, 4. So 3, 4, 3, 0. Let me find the gradient first, which is 4 minus 0 over 3 minus 3, which is 4 over 0, which is undefined. You cannot divide a number into 0 parts. That is baseless, that is pointless. And we can also use the terminology for our purposes as infinity. So we will say that the gradient of a line parallel to x-axis, actually y-axis, the gradient is undefined, and what is unchanged? The x coordinate is unchanged. So the equation of the line is of the format x is equals to a, where a is the x-intercept. Now let me compare the two. Line parallel to x-axis, gradient is 0, y is equals to c. Line parallel to y-axis, gradient is undefined, x is equals to a. So now let me draw 4 lines over here. A line going like this and a line going like this. These are the two things. And then a line parallel to x-axis, and then a line parallel to y-axis. So this has a positive slope, this has a negative slope, this has a 0 slope. So therefore the equation is of the format y is equals to constant, and this has an undefined slope. So the equation is of the form x is equals to a. So in this lecture, what we have studied is that we found equation of line using two different formats. Y is equals to mx plus c. Y minus y1 is equals to mx minus x1. The name for this thing is the slope intercept format. And over here, yes, there is the slope, but there is the point also. So this is the slope and this is the point format. So you can use any which line. And then we talked about the different types of slope, and we talked about that line parallel to x-axis versus line parallel to y-axis. Parallel to x-axis, it's of the format y is equals to c. Parallel to y-axis, it's of the form x is equals to a constant. So let's stop over here and let's meet in the next class.